Good day, viewers. My name is Audrey Polton. Welcome to Lesson 1 for Grade 8 Mathematics. The topic for today is like and unlike terms and adding of expressions. Let's have a look at the lesson objectives. By the end of today's lesson, you should be able to define and identify the number of terms, identify like and unlike terms, add algebraic expressions. Terms in an expression are like maths words. They are made up of factors which can be numbers or variables multiplied together. The variables like x, y, or any letter represent numbers. But even if we do not know what the actual numbers are, we can still work with the variables and do various operations with them. Terms in an expression are separated from each other by plus and minus signs. 3xy, 4p, y to the power of 3, 2a squared, b to the power of 3 are examples of terms. Look at these expressions shown. They all have 3 terms, but because the terms are all different, they cannot be added together. In each case, the terms are separated by plus and minus signs. The signs indicated in red are the important ones to look at. The expression a plus b plus c has 3 terms. It cannot be simplified further. ab plus bc plus ac also has 3 terms as well as the others shown on the screen. Sometimes plus and minus signs do not separate terms. The expressions shown have been changed slightly and now they only have 2 terms. Can you see what has changed? A plus or minus sign which is in a bracket, in a fraction or under a root sign does not separate terms anymore. An expression inside brackets is counted as 1 term. A fraction is regarded as 1 value and is therefore only 1 term. A root sign acts over the whole expression under it and it is regarded as 1 term. Remember, the signs indicated in red are the important ones to look at. So, in counting terms, you have to look carefully and only consider the plus and minus signs which stand alone between terms. The examples shown are more complicated. Do not worry at all about what they mean. Just look at them and notice that each has only 2 parts. Each is a term. Look carefully and only consider the plus and minus signs in red which stand alone between terms. So the rule for counting terms in an expression is: terms are separated by plus and minus signs unless the signs are in a bracket, in a fraction, or under a root. In these cases, ignore the plus or minus sign. You are unlikely to see expressions as complicated as these shown on the screen. The purpose is only to show you how to count the number of terms. So now it is your turn to try and count how many terms each expression has. Do not try to understand them or work out what the answer would be. Just count and write down the number of terms you see in each expression. So how did you manage that? Let's find out. At number 1, there are no plus or minus signs at all. It is all one long term. Number 2. The whole expression is enclosed in a bracket. It does not matter at all what is inside the bracket. It is all one term. Number 3 has 4 terms. Count the parts between the plus and minus signs. Number 4 has 2 terms. There is only one plus sign standing alone. Everything before it is one term, and the fraction a half is the second term. Number 5. This one was the easiest. There are 5 terms. Now that you can identify and count different terms, we can look at a term in more detail. Consider the term 3xy. A term is made up of 2 parts, a number part and the variable part. There can be more than one variable. The number part in front tells us how many there are. The variable part tells us what we are working with. The number part, the 3, is called the numerical coefficient. The letter or variable part xy is called the literal coefficient. Only terms which have the same literal coefficient can be added or subtracted. We call them like terms. In arithmetic, if we had 4 plus 4 plus 4 plus 4 plus 4 plus 4, we could have written it as 6 times 4. In algebra, if we have x plus x plus x plus x plus x plus x, we can write it as 6 times x or 6x. Remember that x can represent any number. How would we simplify an expression such as 6x plus 3x plus 2x? First, notice there are 3 terms. Also notice that all the terms have exactly the same variable x. These are all like terms, so we can add them. We have 6x's plus 3x's plus 2x's. The numbers in front tell us how many x's are being added. Altogether, there are 11 x's. Because we are adding lots of x terms together, we only need to add the numbers in front. 6 plus 3 plus 2 is equal to 11. We don't do anything with the x part. That tells us that we are working with x. So the important parts are the numbers in the front. Here is another example. 5xy plus 4xy plus 3xy. There are 3 like terms, so they can be added. 5 plus 4 plus 3 is equal to 12. So the sum is 12xy. It does not matter what the variables are. They just need to be the same in each term to be able to be added, and then the same variables are written in the answer. Another example is shown. 2x squared plus 5x squared minus 3x squared plus x squared. Remember that the x squared means 1x squared. All of these terms are in x squared. If we start with x squared and are adding, we will end with x squared. 2 plus 5 minus 3 plus 1 is equal to 5, giving the sum as 5x squared. Look at the next example. Did you remember to count the number of terms first? There are 3 terms, but they are all different. These are unlike terms and cannot be added. So the answer is the same expression 4x plus 3y minus 2z. This is where many learners who are new to algebra make errors and get so confused. If the terms are not exactly the same, you cannot add them, so leave the expression just as it is. Here is another expression to be simplified. 4x plus 3y plus 6x plus 5y. There are 4 terms. 2 are x terms and 2 are y terms. To begin with, let's rearrange the expression and write the like terms together. Now, add the 4x and 6x, which gives 10x, and the 3y and 5y, which gives 8y. 10x plus 8y is the final answer. Note that it's not necessary to rewrite the expression. This has been done for ease of understanding. Remember that a positive or negative sign applies to the term immediately after it. Consider the expression 8x plus 5y minus 3x minus y plus 2x. Take a few moments and simplify it. Did you end up with only 2 terms in your answer? 7x plus 4y. There are 3 terms with x. 8x minus 3x plus 2x add up to 7x. There are 2 terms with y, 5y minus y, which add up to 4y. 7x and 4y are unlike terms and cannot be added, so this is the final answer. All of these examples have been addition calculations, even though some of the terms were negative. 8x minus 5x actually means 8x plus minus 5x. However, it becomes very tedious to keep writing terms in brackets, so we shorten it to 8x minus 5x. A positive sign next to a negative sign can be combined to make a negative. You should not be puzzled by this at all, because it is a familiar calculation. They are like terms, so we can add them. There are more positives than negatives, so the answer is positive 3. This is covered in a topic called directed numbers. Look at this next example. 3x minus 4x plus 5x minus 9x plus 2x. There are 5 terms, all with x. They are like terms, but some are positive and some are negative. I find it easier to rearrange the expression with all the positive terms at the front and the negative terms at the end. The positive terms add together to give plus 10x, and the negatives add together to give minus 13x. There are more negatives, so the answer will be negative. The difference between 13 and 10 is 3. The final answer is negative 3x. Here is another expression to simplify. While this looks harder than the previous ones, it is actually easier because all the signs are the same, even though they are all negative. I have rearranged the terms with the variable terms first and the number terms called constants at the end. Now, add all the variable terms together to get negative 20 and all the constants together to get negative 15. There are 2 unlike terms, so this is the final answer. If several expressions are going to be added, like the one on the screen, you can also write the expressions under each other, with the like terms aligned under each other. The columns can now be added to give the final answer as 4x plus 3y minus 3. Many students find this method easier. It is similar to adding hundreds, tens and units that you are familiar with. Remember, when adding, start with like terms and end with unlike terms. We've come to the end of the lesson. Let's have a look at the lesson summary. The rule for counting terms in an expression is: terms are separated by a plus and minus sign, unless the signs are in a bracket, in a fraction, or under a root. In these cases, ignore the plus or minus sign. Only terms which have the same literal coefficient can be added or subtracted. We call them like terms. All like terms can be added. I hope you have enjoyed the lesson. Until next time, goodbye.